There we go. Okay. Oops. Fantastic. All right. Hello, everybody. If you can see / here, a message would be helpful that you can see or hear. And we'll get started in a couple minutes. Making sure my marker is writing. Lovely. And hopefully you can see that as well. So what we're going to do, the plan, is that I'd like to just talk to you first of all, and check in. And I'd also like to hear if there's any questions you have, like general questions. And after that, I would like to maybe go over one or two topics for you, or one or two things from the packet specifically, just to kind of get us into the swing of things. We can go towards the pretty late or more difficult stuff if you're far and are stuck in a certain place, or we could start at the beginning just to get you started. It's whichever is going to be helpful point of the packet right now. Okay. And if you have questions, you can comment in the live chat. You can reply to the email. Just make sure you don't hit reply all. My Canvas messages should be open. If you have me on Remind, you can send me something there. Just wherever, if you have questions or things that you want to know. There we are. Let me actually get this up here for you to see. There we go. Lovely. Good, good. All right. One second. Let me get these out of here and put this over here. All right. Fantastic. Part of what I'm doing today is kind of, I've done a preliminary test of my setup and my equipment, but I also wanted to do a second test with you guys here, so that you guys can tell me if there's anything that you might need that isn't there right now. Then you can let me know, or if something isn't showing up properly, if audio levels need to change, then you can tell me that, or if you have suggestions as to how for the setup. But I'm hoping, since if you don't know, what's currently on the docket is an AB schedule, an every other day schedule, for DHS, and so my thought is that for some of those days, what I will do is I will stream what we're doing, like I'm doing right now, and that way your only kind of assignment is to watch it, follow along with the notes, and show me that you've done that. And that way we can get through more stuff at a nicer pace, and not put as much on you to do at home. As opposed to giving you a whole bunch of homework assignments to do at home, just to be tuned into class. And that's what I'm hoping to do. So I'm wanting to make sure that this setup and all that stuff is going to kind of work out for us. And so that's a lot of what today is for, is just to be able to make sure that you can find what you need. Actually, one thing I'd like to know, if you're able to do that, I can't open Canvas doesn't open up until the start of term, which right now I think it's listed as the 17th, although that's subject to change for when we're actually going to start the year. We'll see at the board meeting later today. But I kind of wanted to give you an idea. This was a bit more urgent when we were going to start the year, exactly on the 17th. But I still wanted to go ahead with today so that you kind of got used to what you were going to see, so that you can ask questions if you wanted to, and just so that we can get used to how this might look. So with that, I wanted to start here by going over the information that I put out in my last email in case you didn't get that or see that, or in case it's been a while. So I asked for emails, and I heard from quite a few of you. And those of you that I didn't hear from, I used your school email to get this set up. So let me just drag out this email so that I can go through it and make sure that I have gone through everything. Here we are. So just to say that I'm glad you signed up for AP Calc. I wanted to thank those of you who contacted me with your preferred email. A couple things I wanted to point out about the summer assignment. I attached it again to this email that I sent out in case you misplaced it or never got a copy or anything like that. If I got a couple questions because it says that you have to do your work on separate pieces of paper and put it in a binder and turn it into me that way. You can certainly do that, and some people prefer to do that. My biggest thing is organization. And so my biggest thing on this assignment is that it's organized in some way so that I know where to find things. So as long as your work isn't completely all over the place, if you want to do it right in the packet, if you want to do it on a separate sheet of paper, just as long as when you turn it into me, it is organized and I can find everything that you need to do. And if I didn't say this before, pass number 70, that's the stuff about limits. If that's on your packet, then I apologize. It wasn't meant to be on the packet. But we're going to do those separately once the school year starts up. And so it used to be on the packet, and I used to give some credit for doing that. But I find it's easier if we just start by going through it in the year, during the year, instead of in the summer packet. And so let's hold off on doing those. That's not required to do that. And it's going to be due on the first day of class. And as far as meetings, my plan is to have some more of these meetings, maybe once a week around. It'd be great to know from you guys if there is a specific time or time in the day that's going to work for you to do this. So please let me know if there is some kind of time or schedule of time that we can meet that's going to work best for you. So I know we did that. Those of you who were in my AP classes, we had planned a specific time on Fridays to meet every Friday because that's what worked best for people. So I'm hoping to do something like that before we start the year. Now, why have these meetings? Partially, it's just because I want you to kind of get acquainted and get used to what we're going to do for remote. I also know that there are a few of you that have asked to meet with me and to go over some things, and so I wanted to give that opportunity. I also want to make sure that you're on a decent footing with the summer packet and that you're kind of on the right track. I want to give you some semblance of guidance, and I don't want you to feel like you're stranded out there. And so I wanted to give you some help and support in that way before we start the year. It's not to give you extra things to do. It is to help you with the things that you do need to do. So with that, unless you have any specific questions, unless anyone has anything specific that they want to send to me or let me know, then I'm going to go ahead and go through a couple of these problems, just to kind of get us. And my plan is to focus on the start of the packet and go through, page or two. Not every problem, but a couple problems on each page for a couple pages, and then that's what we'll do. By the way, you'll notice that each page gives an example for how these things work. And so it'll give a short explanation, and then it'll give an example, and have it work through, and then it's going to ask you to actually do the problems, actually do the work. So that's what we're going to focus on. I'm going to do about 2 of these, and then we'll move on to the next thing. All right. And I'm going to take myself away a little bit, because all I'm going to be doing is blocking the board. I'll come back before we finish here. There we go. Okay. Make sure that it's writing and that you can see the writing. Looks like you can see the writing. First time I tried to use the smartboard the other day, it was way off kilter, and I had to completely reconfigure it. So wanted to make sure it was working today. All right. Now, here's the idea of these ones, is that what we don't want is no fractions and fractions. Okay, so if there's a fraction and a fraction, then we want to get rid of it. That's the whole idea. And so that's what we're going to work on. If there is a fraction kind of nested inside of another fraction, that's what we want to get rid of. And so what we're going to do in order to do that, if we're trying to simplify an expression, if we're trying to simplify something, then what we can do is we can't add or subtract something to both sides, because there's no sides to do that with. So what we have to do, one way we can simplify is by multiplying by 1. And we get to choose how we write 1. Right? 1 can be 1, but it can also be 5 over 5 or negative 1 over negative 1. So we're going to multiply by 1 in a way that's going to get rid of or cancel the fraction and a fraction. All right? And so for this first one, we want to look at the fraction that's nested inside of the other fraction. And so our goal is to get rid of this. Okay? Because this a is on the bottom, is a fraction that's inside of another fraction. We don't like that. All right? So that's our overall goal. This a needs to go out of the bottom. So we're going to multiply top and bottom by a. And what that's going to do what that's going to do is it's going to cancel the a's here. But, okay, a cancels here, but it needs to multiply with everything. So it doesn't quite completely cancel. 25 minus, we have a times a is a squared. Over, a gets multiplied by everything here. So we have a times 5 plus a, which is going to be 5a, 5 times a, and then a times a squared. Boom. Now, if you want to get fancier with simplifying this, we can get fancier. Okay, because check this out. 25 minus a squared, well, that's a difference of squares. You should recognize that as a difference of squares. So that's going to be 5 plus a times 5 minus a. Over, all over, we've got a. An a can come out of this, can be factored out of this. We've got 5 plus a. And guess what? Those cancel. And so we can just have 5 minus a over a. Now, we are not going to always want to cancel in this way. Okay? We're not going to always want to cancel in this way. So sometimes maybe we want to know what happens when a is negative 5. Because this doesn't show that. And that's kind of the first thing we're going to talk about is, well, what if a is negative 5? What if we want to know what happens when we plug negative 5 into this thing? Or what if we want to know what happens when we plug 0 in? Because then we have 25 over 0, and uh-oh. So sometimes we want to look at what happens when we plug those pieces in. But sometimes we just want to know how it's going to look and how it's going to behave. So that's going to, canceling is going to let us do that easier. Okay, it's going to be, simplifying is going to be all about what is our goal. Okay, and I'll talk more about that as we kind of start the year, and you'll see more what I mean as we go on. But just keep in mind that there isn't a absolutely correct simplified form. There's going to be forms that are going to be more helpful for us on this problem. Look at it more that way. And there's a lot of different ways that we can do that. But let's look at the next one I want to look at. Next one I want to look at is number 4. All right, so I'm going to switch to the board, and we're going to look at number 4. Let me check if we check on one thing first before I do that. Okay, we're good. Number 4, again, our goal is to get rid of the fractions inside of the fractions. So what we don't like is that we've got this big fraction, okay, all of this over all of this, okay, but then we also have the little fractions, the x over x plus 1 and the 1 over x. And what we want to do is we want to get rid of those tiny fractions inside of the big fractions. But this time we have multiple things that we are trying to get out of the bottom. We have multiple things we're trying to get out of the bottom. So we're going to multiply top and bottom. And we want to multiply by everything that we want to get out of the bottom. So we have x plus 1 that we want to get out of the bottom. And we have an x that we want to get out of the bottom. With both of those expressions that we want to get out of the bottom. Over x plus 1 times x. We want to multiply by the same thing on top and bottom so that we're still multiplying by 1. Equals. Big fraction. So on this big fraction, on the top, we have these x plus 1s that cancel. Okay, and so then we just have x times x being x squared. All right, minus, on the other hand, we have the x's cancel, the one on the 1 over x. X cancels with this x, and we have the x plus 1 being multiplied here. Okay, and we'll simplify that in just a second, but let's look at the bottom first. On the bottom, x plus 1's cancel, and we have an x times x being x squared. And then we have plus, we have x's cancel, and we have 1 times x plus 1. So let's clean that up a little bit. We've got an x squared minus, this minus gets distributed to the whole thing. Minus gets distributed to the whole thing. So we have minus x minus 1. And then we're all over x squared plus x plus 1. And there's our answer. Put box around it. Okay, so the overall goal is that anything let me come back here. Overall goal is that anything that is on the bottom, that is a fraction inside of another fraction, we want to get rid of. And then we want to cancel, see what cancels out of each piece of the expression. Okay, because and the reason we're talking about this is in calculus, expressions can get really messy quite fast. And when we start messing with messy things, then it gets even more messy. And so a lot of times, one thing that you'll hear from me this year is simplifying now or later. Now is usually better. That's something I picked up from my calculus teacher. Simplifying now or later, now is usually better. So what that means is if we can turn this into this, then when we do something with this expression, it's going to look a lot cleaner. It's going to look a lot nicer to mess around with this expression than with this expression. Or it's going to be a lot nicer to mess with 5 minus a over a rather than all this. Even though they mean the same thing, except at when a is negative 5. And again, we'll talk about that when we get to the first chapter. But just kind of put that in the back of your head, that these expressions might look different when that happens. Okay? And if you have questions as I go, feel free to send them to me. I will be kind of checking in after each problem to see if anyone has any questions. I actually want to know how this looks because I froze the screen. But I don't think the screen would be frozen on your end. No, it's not frozen on your end. Okay, interesting. Good to know. because that's the projector. That's not the desktop itself that got frozen. And so that makes sense that it wouldn't freeze the screen on your end. Good to know. This is why we test these things. All right. Again, what I'm looking to do is kind of alternate between trying an easier one first and then trying a like medium to hard. So my aim is to alternate between those. Okay, so we'll do 7 and we'll do 10. And so one way you can think of a function, okay, if you've never seen this before, okay, I've shown this to some of you, but one way you can think of a function is like a machine. Okay, so here's my machine, all right. I know those of you who have taken my classes in the past have missed my spectacular drawings, but here is my machine f of x. Okay. And what it's going to do is it's going to bring in different things, and it's going to equals 2x plus 1. Okay. So what I'm trying to show here is that no matter what comes in to whatever expression we're looking at, it's going to take that thing, all right? It's going to take it and double it and add 1. That's all the machine does. And that's what makes something a function, is that when I put something in, I know exactly what it's going to do and what's going to come out of it. Okay? That's what we mean by every input has exactly one output. That's what makes something a function. Okay? Every input has exactly one output. And so if I put 5 in, all right, I know I'm going to get 11 out every single time, because it's going to take 5, it's going to double it, and it's going to add 1, no matter what. No matter what comes in, no matter what else is going on in the world, if I put 5 in, I know what I'm getting out. If I put 5 in and I get 11 out, but then sometimes I get 12, sometimes it just works like that, then it's not a function. Then it's not working like a machine, because it's taking something in, and then sometimes it spits something else out at random. That wouldn't be good. Okay, so that's what makes something a function, is if I put something in to the function, I know exactly what I'm getting out. And so if we look at f of 2, well, 2 is coming in. Okay, well, if 2 comes into this machine, what this machine is going to do, okay, is it's going to take that number 2, all right, it's going to double it, and it's going to add 1. 2 times 2 is 4 plus 1 is 5. So when I put 2 in, I get 5 out, and I always get 5 out if I put 2 in. So that's the idea. That's going to come in handy in just a second when we look at compositions. But for now, let's do g of negative 3. G of negative 3. Okay, so it's going to take negative 3. G is a different machine that takes whatever you put into it, it squares it, then it doubles it, then it subtracts 1. So let's do that. that equals 2 times negative 3 squared is negative 3 times negative 3 is a positive 9 minus 1. So that is 18 minus 1 is 17. There you go. Negative 3 comes in, 17 comes out. Now let's look at 10. Okay. G of f of m plus 2. Okay. Now this time what's going in is not a number, it's a whole expression. Okay. What's going in is an entire expression. So we're going to build from the inside out here. Okay. G of f of m plus 2. Well, f of m plus 2, we're building from the inside out. F of m plus 2 means that m plus 2 comes in, all right? So instead of x, in place of x, anywhere there's an x, I'm going to put an m plus 2. Then we're going to take that m plus 2, we're going to double it and add 1. Boom, boom. All right, so then we're going to distribute. This part should be quick. 2m plus 4 plus 1, so that's going to be 2m plus 5. Okay, that's f of m plus 2. Simplified down a little bit. Okay, but we want g of f of m plus 2. Okay, well we know that this is 2m plus 5. So what we're really doing is we're doing g of, brackets, 2m plus 5. Okay, this piece of underline, we've already simplified it out, and it's already 2m plus 5. So what we're going to do is we're going to do g of f of m plus 2, which we know is 2m plus 5. Equals. So we're going to take that 2m plus 5 that we just simplified, and it's going to go into g. Which means that g is a factory. It's a machine that's going to take things, it's going to square them, it's going to double them, then it's going to subtract 1. Okay, and what are we doing this to? Well, what's coming into this machine is 2m plus 5. There we go. We've put it into our machine, and now it just needs to run through it. Here we go. 2 times, let's see, that needs to get squared. This is not, okay, here's a common thing. All right. This is not 4m squared plus 25 because, think about it, if you're squaring it, you're multiplying it by itself. So 2m plus 5 squared is 2m plus 5 times 2m plus 5. I usually call this the second most common mistake in algebra. So make sure you don't fall for it here. So that will get distributed. I'll only do this once. You already know this. You already know. By the time I wrote this out, most of you probably already were like, oh, that's right, if you did do it wrong. If you did it right, then great. But I just wanted to catch those of you because I'm sure there were quite a few people who kind of rushed through this part and missed it. So we got 4m squared plus 20m, 20m, plus 25. Okay, there we go. So that is what goes in here. 4m squared plus 20m plus 25. And you probably learned some sort of pattern shortcut for that, like square the first, square the last, multiply together, and double. And you probably built that routine in your head. I just wanted to remind you of that routine because it's a common thing that people, if they're rushing through it, then they miss it. Now we need to double it. So 8m squared plus 40m plus double 25, that's 50, but then minus 1, so plus 49. Okay. And this is our final answer. This is our final answer. So we worked from the inside out. We worked from the inside out here. What we did was we took the m plus 2 and put it into f, and we got out a simplified thing for that. Then that all went into G. That all went into G and went through the machine of G and then got out another expression. So that's the idea behind a function inside of another function. And there's some more practice with these down here with a completely different function. Oh, sine of x. Don't forget, one of the first things I'm going to do is make sure and drill into our heads some practice with figuring out different trig values, because things like sine of pi over 2 and sine of 2 pi over 3, hopefully the unit circle's drilled into your head by now. If not, we're going to re-drill it into your head because a lot of AP Calc is going to be non-calculator. You're going to have to say, what's the sine of 2 pi over 3? And you're going to want to come up with that pretty quickly without a calculator. So we want to make sure that we can do that. We'll talk about that more at the start of the year. It's going to be one of the first things that we kind of come back to and review and drill. Okay. Let me do this. Let me do it this way. We'll go through one more page and then we'll call it good for now. I'll come back to 17 and 18 actually. We'll just do one more problem. Okay, and these should be hopefully quick and easy. Again, a large part of this should be like a reminder, a quick refresher of, oh yeah, that's how that works, and then we can go on. So, for some of you this might seem pretty basic. For some of you, it takes a little, oh yeah, that's how that works, and then you should be hopefully good. X and Y intercepts. So what we want to do is for the x-intercept, that's when it crosses the x-axis, and so the y-coordinate is 0. For the y-intercept, the x-coordinate is 0. So all we need to do is plug 0 in for x, plug 0 in for y, see what we get. That's what we're going to do. All right. Let's start with the y-intercept, and we're going to do number 20. The y-intercept is going to be when x is 0. Doing the y-intercept first because it's easier. Here we go. X is 0, so we're going to make x 0 and figure out what y is. 0 squared plus 0 minus 2. Well, that's just negative 2. So our y-intercept is 0, negative 2. That's where we cross the y-axis. And hopefully you should have an idea of what this graph looks like. You should be able to give me in 5 to 10 seconds a rough sketch of what the graph looks like of x squared plus x minus 2. You should be able to tell me a couple things about it. So think about that as we do the x-intercepts here. x-intercepts, that is when y equals 0. Oh, here we go. Now it gets interesting because y is 0. There's a quadratic. And hopefully you can catch that this one is factorable. And hopefully I shouldn't have to go through how to factor. You should know that this factors into x plus 2 times x minus 1 because since we're multiplying being negative, one has to be positive, one has to be negative. This tells me the positive's got to outweigh the negative, so positive 2, negative 1. Oh, but those aren't the x-intercepts because we got to set each part equal to 0. And remember that we do that, okay, because if we're multiplying two things together to be 0, the only way that can happen is if one of them is 0. Subtract 2 from both sides. So x equals negative 2. Add 1 to both sides, x equals 1. Right, so negative 2, positive 1 are my x-intercepts. So my x-intercepts are negative 2, 0, and 1, 0. Okay? And even another cool thing about x and y intercepts is that, if you are having trouble with the rough sketch, then, let's use these 3 points that we just got. We've got, without even making a table, we've got 3 points on our graph. So let's make those 3 points and see what we can come up with. And hopefully, as I plot these, as I give kind of an approximation of where these points would go, hopefully you would be able to tell me a couple of things about what this graph looks like. For example, you should know that if we've got an x squared, then you should know that that is a parabola. Right? And you should know that that's a parabola that opens up. Parabola that opens up. Okay, so with that, that should be able to give me a pretty good approximation of what this looks like. And we could do a whole bunch of things with like figuring out where the vertex is and the axis of symmetry, but you should be able to kind of roughly graph a parabola that opens up. The vertex is where we had a maximum or minimum. That should be halfway in between the x-intercepts. Okay, but that's the idea, is y-intercept is when x is 0, x-intercept is when y is 0, and sometimes solving for one of those is going to be a little bit easier, a little bit harder than others. Okay, that's about it for now. Thanks to those of you who came by. I hope you found it helpful. Let me bring myself out here. Get rid of this and get rid of this. And we didn't need that. Okay. Hopefully you found that helpful. And my plan, my current hope, is to have one of these meetings about once a week. We'll see how that works. We'll see how we're going to do that. Hopefully, I can get a hold of you through Canvas or some better way soon, so that I can kind of put things out there that you'll be able to see it, and it won't be as a last-minute thing for you to check your email 10 minutes beforehand. But what my hope is that we can have this a variety of ways. I might do my next meeting on Zoom so that I can actually talk to those of you who come by and see how we're doing and see what things we want to do and go over. I think that might be helpful to a lot of you. So I'm hoping that we can do that sometime, probably middle of next week. And think that is more or less it. If you have any other questions or thoughts, then you can contact me on email or Canvas or any of those things, and let me know. So that's all for now. If you have questions, let me know. I'm here to help. And I will talk to you all again soon. Take care.